Hello, we are going to be talking about is X, Y a solution to the system of equations? So in these example problems, we're going to be given an ordered pair and we're going to be asked, is it this ordered pair a solution to the system of equations? And we have to figure out if yes, it is or no, it's not. We have to remember that a point or that ordered pair is a solution to the system of equations if by plugging the point in or substituting the point into the equation, the point is going to result in a true statement. Or when we say a true statement, we say like we had the number 2 is equal to 2. This would be a true statement. But then let's say if our answer after substituting the ordered pair into the equation, if we result in an equation that looks like 1 equals 3, this is not a true statement, and this is going to tell us that no, that is not going to be a solution to that particular equation. And when we talk about a system of equations, this is where we're going to have two separate equations. So in order for the ordered pair or the point to be a solution, it has to work, it has to provide a true statement for both of the equations that we have in order to be yes, that it's a solution to the system of equations. If it works for one, but it does not work for the other, that means that no, it's not going to be a solution. So let's take a look at some examples here. So our first example says, is the point 2, 10 a solution to this system of equations? We have to remember that when we have this ordered pair, 2, 10, the ordered pairs are written as x and then y values, okay? And so that's how we're going to substitute that in, which means that our x is going to be substituted for 2 and our y is going to be substituted for 10. So anywhere when we have these equations, anywhere we see x, we're going to plug in a 2, and anywhere we see a y, we're going to plug in a 10 for this particular question. It is going to change depending on what the ordered pair is and what the equations we are provided with. So let's first look at this first equation. We've got y equals x plus 8. And so our first here is going to be our y. And so we're going to go to our ordered pair and we're going to say we're going to substitute in the number 10 for y. Okay, is equal to, and then our next here is x, which we're going to plug in our 2, substitute in the value of 2, and then plus 8 is just going to stay the same. Okay, once we have this written, we can see that we can combine terms by adding or subtracting, multiplying or dividing, whatever the operation says. So in this case, 10 is just going to remain the same. 2 plus 8, that would give us 10. And so we can see that, yes, this is a true statement. This is going to tell us that, yes, this ordered pair or this point is a solution to this particular equation. Now, when you have a system, it's really important that if you try the first equation, we don't just assume, okay, yes, it is going to be a solution, because if it works for one, but it does not work for the other, then no, it is not a solution to the system of equations, okay? So even though we have a yes for this first one, we still want to make sure that we try the second one. So we're going to do the same thing with substituting. And so this first, in the parentheses, we're going to plug in our y, which would be our 10, is equal to, this coefficient that goes with x is still going to stay as the coefficient, and we're only going to substitute the value of x for 2, and then plus 3. Now we can go through and we can solve. We can say 10, order of operations tells us we're going to multiply first. So 10 times 2 is going to give us 20 plus 3. And then bring this down one more time. 10 is equal to 20 plus 3 is 23. Now, looking at this, 10 is not equal to 23. This is not a true statement. This is actually false. 10 will never be equal to 23. So because plugging in or substituting in this ordered pair into the second equation did not result in a true statement, this is going to mean that no, this ordered pair 2, 10 is not a solution. Okay, and that's, again, that kind of reestablishes the importance of yes, if you try the first one and it's a yes, make sure you still work on the next one, because if the first one is a yes and the second one is a no, it means that your answer will be a no for this particular ordered pair. Let's look at another example here. Now we have the ordered pair. We have is 1, 2 a solution to this system of equations? Okay, so again, we have to remember that this ordered pair here of 1, 2 is written as our x and then our y. And so anywhere we have a value or the variable x, we're going to substitute in the number 1. And then anywhere we have the variable y, we're going to substitute in the number 2. So when we look at this first equation, we've got 12. We're going to plug in for x, we're going to plug in a 1, and then plus, and then for y, we're going to plug in the number 2. So this equation looks the same, except for those variables are what we are replacing with numbers now. We're substituting in numbers. So now we can solve. We have to remember order operations. We're going to multiply or divide first. So 12 times 1 would give us 12, plus 2 is equal to 14. 12 plus 2 is equal to 14. So we would say that yes, this is a true statement. But again, it's really important that we keep going and we try the second one to make sure that we get a yes for both. So now we have 4 in our parentheses. For x, we're going to substitute in the value of 1. And then plus 7 times for y, we're going to substitute in the value for 2 is equal to 18. So then we're going to do our multiplication first. So we're going to multiply 4 times 1 and 7 times 2. So 4 times 1 is 4 plus 7 times 2 is 14 is equal to 18. And then 4 plus 14 is equal to 18. And so we can see that this is also going to result in a true statement, which means that when we look at this, we got a yes for both when we plug in that ordered pair. And so we would say that yes, 1, 2 is going to be a solution. So is a solution to this system of equations. All right, we're going to keep going, practice a couple more. So looking at this one, now we have a different ordered pair. We have is 3, 1 a solution to the system of equations. So again, we have to remember that our ordered pair is written as x and then y. And so anywhere we have the value or the variable x, we're going to plug in the value of 3. And anywhere we have the variable y, we're going to plug in the number 1. So we're going to go through this equation, start with the first one. So 3, and then we have an x. And so instead of writing x, we're going to plug in the value of 3. We're substituting plus 3. Now we have y. So instead of the 3 for x, we're going to plug in a 1 for y is equal to 12. Now we're going to do the same thing. We're going to start with our multiplication first. Multiply each of these separately. So 3 times 3 is 9, plus 3 times 1 is 3. And that's going to give us an answer of 9 plus 3 equals 12. So 9 plus 3 does equal 12. And so this is going to tell us that this first one is a true statement. Again, it's very important we keep going. We try that second one, make sure we get a yes for both. So we're going to have 12. Our x, we're going to plug in the value of 3. And then our y, we're going to plug in the value of 1 is equal to 13. So now we're going to start with this over here. 12 times 3, okay, is going to give us an answer of 36. Plus 1, we don't have to do anything with the 1. There's nothing to multiply, no coefficients attached to that original variable y. So we would just bring down the 1 is equal to 13. And then 36 plus 1 is 37. This is going to result in not a true statement, which means 37 does not equal 13. It's never going to equal 13, which means our ordered pair of 3, 1 is not a solution to this system of equations. And again, this shows us that when we tried the first one, we got a yes, and then when we tried the second one, we got a no. And so we have to get yes for both in order for it to be true. In order for this point to be a solution to the system of equations, has to be a yes for both of our equations. We'll try a couple more examples. So moving on to the next example here, we have is -5, -1 a solution to the system of equations? So we've got our ordered pair of -5 and -1, and it's never going to change how the ordered pairs are written. It's always going to be x and then your y. And so anywhere we have the variable x, we're going to plug in a -5, and anywhere we have the variable y, we're going to plug in a -1. When we look at this first equation, there's something kind of different about this first equation that maybe you have already noticed. We don't have a variable of x. We only have the variable y, and that's okay. You don't have to add the variable x, okay? You're not going to add the variable x. What we're going to do is we're just going to use the variable we have of y, and we're going to plug in a -1 for y, and it says that y is equal to -1. So -1 is equal to -1. This is a true statement. Now, this might seem easy, too easy, and that's okay. If we have this, y equals -1, like I said, we're just going to use the variable that we're given from the equation. We don't need to add a variable of x. We're not going to add a variable of x that would change the equation, and it would not be the question that we're being asked. So this would be a true statement. And then we're going to move on to the next one. We've got 3. Now we do have the variable x, so we're going to plug that in. We've got 3 and a -5 plus y, which is our -1, is equal to 16. Now, 3 times -5, we're going to do our multiplication first. So 3 times -5, we have to remember those rules with integers. So multiplication, if the signs are the same, we'll have a positive answer. If the signs are different, we'll have a negative answer. So we're going to multiply just as normal. 3 times 5 is 15, but we can see we have a +3 and a -5, which means our answer is going to be a negative. The signs are different. Then we have plus, we could say plus a -1 is equal to 16. Now, with the rules with adding, if the signs are the same with integers, so we've got either 2 positives or 2 negatives, we would just add those numbers and we would keep the sign the same. So in this case, these are both negative numbers. So -15 plus -1, 15 plus 1 is 16, and then we're going to keep the sign that goes with that. -16 is equal to 16. Now, even though we have the same number, we have 16 and 16, one of them is a negative and one of them is a positive. So if you think of about a number line, a -16 is going to be further to the left and a +16 is going to be to the right of 0. And so these are actually not the same numbers, okay? If the signs are different, you've got a negative and a positive, they're not the same numbers. So in this case, this is not a true statement, which means -5, -1 is not a solution. It is not going to be a solution to this system of equations. All right, we're going to move on to another example, just a few more, just to practice. So let's take a look at this next one. We've got, is -8, 6 a solution to this system of equations? So we know that we've got our ordered pair of -8, 6, which means this first one is our x, second one is our y. So anywhere we have the variable x, we're going to plug in a -8. And anywhere we have a y, we're going to plug in the value of 6. So here we have y equals 1/2 x plus 10. So we are going to plug in for our y. We're going to plug in, substitute in the value of y as 6. Our coefficient is going to stay as 1/2, and now we have this variable of x. So instead of x, we're going to substitute in the value of -8 plus 10. Now 6 is going to stay the same. Now we are going to multiply first according to our order of operations. And I know we're looking at this as a fraction, but remember fractions, we can write this as 1/2 times -8. And remember that anytime you have a whole number, we can write this as a whole number over 1. So this is going to be much easier to multiply across. We would just multiply straight across. 1 times -8, -8, and then 2 times 1 is 2. And now anytime we have a fraction, we can also look at this as a division problem. So we can say -8 divided by 2, which would give us a -4. Okay, so this is going to result in a -4 plus 10. And then we have to remember too that our rules with integers with adding, if the signs are not the same, that's where you're going to look at the larger absolute value, which is 10, and we're going to end up actually subtracting. Okay, and I know that sounds a little funny because it says we're going to add, but since the signs are not the same, we have to think about what the difference between that negative number is and that positive number. Or we can also think about creating those zero pairs where we would have -4 counters, and then we'd have +10, and how many zero pairs can we cancel out between the two? And we would actually be left with 6 is equal to a +6. So this is a true statement. If we take the absolute values, 10 minus 4, we'd get 6, and then we look at which one was the greater absolute value, which was a +10, and so we would keep that number. And I know we're looking at this and we might be thinking, well, that's not a positive sign, that's an addition sign. But remember, it can double. So it can double as an addition sign would be a positive that goes with that number. Or if it was a subtraction sign, it would be a negative sign that would go with that number. So that in that case, this would work as a +10 and a -4 as two separate terms. Now we can look at the second system of equations, and we've got y. So we're going to plug in a 6 is equal to 1/4. Now we have our x, which is going to be a -8 plus 8. So we can look at this exactly the same as we did over here. We've got a 1/4 times a -8. And we would write this whole number over 1 and just multiply across. Get -8 over 4, and then we could divide and say -8 divided by 4 would give us a -2. So we'd have 6 is equal to -2 plus 8. And again, we're left in a situation where we're adding, but we're adding a positive and a negative, so the signs are different. So this is where we're going to look at the absolute values. Okay, absolute value, we're looking at a 2 and an 8. We've got a -2 and a +8, but we want to look at the absolute values, and we're going to say 8 is greater than 2. And so then we take 8 and subtract 2, which would give us 8 minus 2 is 6. And since the 8 was the larger absolute value and the positive sign was associated with the 8, that means our answer will also be positive. So this is also a true statement. So we would say, yes, this is going to be a solution. -8, 6 is a solution to this system of equations. All right. And then we've got one more example we'll go through. So now we have the ordered pair of 7, -2, and we need to decide, is it a solution to this system of equations? Okay, again, we have x and then y. So anywhere we have an x value or an x variable, we're going to plug in the number 7. And anywhere we have a y, we're going to substitute in the number -2. So looking at this first one, we have 8, and then we have the variable x. So we're going to plug in 7 minus 20, and then we have a y. So we're going to plug in -2 is equal to -4. So 8 times 7, we're going to do our multiplication first. So 8 times 7 is 56. And then we can multiply. We can say, we can actually say -20 times -2, which would give us a +40. Remember that sign, even though it's a subtraction sign, it can double as a negative sign that goes with that number next to it. So this would be minus 20 times -2 or a negative 20 times -2 in this case. And then we would say 56 plus 40 is 96. And 96 is never going to be equal to a -4. So the good thing about this one is since this was the first equation we worked on and we got a no, we can see that this ordered pair, this um, point that we have is not going to work with this equation. We can automatically say that no, this is not going to be a solution. So 7, -2 is not a solution to this system of equations. You can keep going and you can try the other one to substitute in, but remember the rule with if we're trying to figure out if an ordered pair or a point is a solution to a system of equations, it has to be true for both of those equations. It cannot be true for just one. It has to be true for both of them.